This video introduces matching file names using path name expansion. The Bash shell has a path name matching capability called globbing, which comes from an older global command file path name expansion program of years ago. The Bash shell globbing capability is commonly called pattern matching or using wildcards. Using meta characters that expand to match the file and path names being sought, commands can perform on a focused set of files all at once. Let's start with pattern matching. Let's show some examples of the use of the asterisk and the question mark wildcards. Given a set of files with a number of different characters in their names, let's look for anything that begins with an A. The asterisk matches 0 or more characters, fundamentally any number of characters. It finds able and alpha. Looking for files that begin with a B. Looking for files that end in an A. The question mark allows us to match one place, one character. If you'll notice, the files in there: cache, cashier, cast, and castle. Let's list only those that start with CAS with one character after that. This matches only cache and cast, but not cashier and castle. If we replace the question mark with an asterisk, sure enough, we match all of them. Let's find all files that begin with dog, D-O-G, followed by anything. And remember, because the asterisk matches 0 or more characters, this is actually legitimate that it matches dog even though there aren't any characters that follow that. You've already used the tilde to go to your home directory. And if we echo what tilde expands to, it does match your home directory. And you can also use this to reference other people's home directories also. The tilde followed by a legitimate username, and I have created a user called Bob here, will return that user's home directory. So you could use that in command lines. If you attempt to do this with a username that does not exist, and I don't have a SU account on this machine, it won't find anything. And you'll notice with the use of any pattern matches, when you ask for a pattern that can't be matched, it will return the original request as text, which lets you know that you didn't actually match anything. The next one to learn is brace expansion. You can use braces to generate discretionary strings of characters. The list of strings is a comma-separated list inside of the braces. And brace expansion can actually be nested. We'll start with something simple. For example, I want to create a bunch of files. I'm going to use the touch command to just generate files. And I'd like to create 3 of them: file A, file B, and file C. Notice a comma separated list ending in .txt. The text that is on the outside of the braces is what's going to be duplicated in each and every file name. Within the braces, those are my choices. Let's see what that created. Notice 3 files, file A, B, and C. Now it can be a comma separated list of just about anything. But you can also use range syntax when you're talking about single characters or numerics, for example. For this one, just to show it being done, Let's replace the ABC with a range that goes from A to J. Oh, A to K. So that's using range syntax inside of brace expansion. The shell also handles what's known as command substitution. Command substitution allows the output of a command to replace the command itself when embedded inside another command. For example, let me do an echo command where I want to echo out today's date. We use backticks around the date command. The embedded %A is a date command syntax that returns the day of the week. The backticks are an older syntax from the Bourne shell that are generally discouraged in favor of the easier to implement parentheses syntax of the bash shell. So let me do another example that uses the newer bash shell syntax instead. The %M is going to return the minutes, the %L is going to return the hour, and the %P is going to return AM or PM. So what was inside those dollar parentheses sets was evaluated first, replaced on the command line, and then the echo command was done. The $ character is used to initiate command substitution, but also you'll see it in variables and variable names and in other shell tricks like arithmetic expansion. Let's show an example of creating a variable. So let's run the hostname command, which returns the fully qualified name of this machine. And let's put that into a variable called host. And I can now see the contents of that variable by treating it as a variable, putting a $ in front of it with an echo command. Now, this is known as variable substitution. We replace the variable with its contents before the echo is done, and then the echo shows you what the contents were. There are times when you're going to want to protect things that you're trying to print or echo from being expanded. Sometimes you just want to print out a $. For example, if I wanted to print out the variable name itself, user, well, user is a system variable that has your username in it, and I'm logged in as student. If I just wanted to print $user, I can protect that. There are two ways of protecting. So to remove special meaning from meta characters and parentheses, we use quoting or escaping to keep them from being shell expanded. Escaping is the use of the backslash. I'll put a backslash in front of this $, and it fundamentally says, the next character, take away its special meaning, I am protecting it. So we echo just $user instead of the contents of $user. Sometimes you want to protect many characters, and you could escape each and every character that requires protection. That can get a little difficult. So instead we can use quoting. If you put quotes around a whole string of character that needs protection, it will protect the whole string. Now, double quotes will actually keep meta characters from expanding, but what you'll notice here is there's a variable in there, the $host variable, and Command substitution and variable substitution will still occur inside double quotes. But the meta character expansion, all those asterisks, they will not be expanded, they'll be protected. So again, notice the variable did get substituted. In this next example, I'm going to put both a variable and a command substitution using the bash syntax of $parentheses inside double quotes. And notice that variables inside double quotes get expanded and command substitution does end up being evaluated. So how do we keep that from happening? If I want to actually take text literally, just replace the double quotes with single quotes. And this will force all text to be taken literally, even the variables and the command substitutions. They will not be expanded. They will not be substituted. So you get literal. The question mark is actually a special character that is used for history expansion also. And notice that it also printed as a literal and was not interpreted. This concludes the introduction to matching file names using path name expansion.